Alright, today we are going to look on the concept of Milliequivalents. The concept of Milliequivalents has got certain steps to understand before you proceed. There was a session when I was explaining on different ways of expressing the concentration of the fluid, one of which was the Milliequivalents. So apart from the ratio strength, percentage strength, milliequivalents, millimoles, millosmoles, there are 100 other ways of expressing the concentration of fluids in that manner. So in this case, we are going to look at the milliequivalent. And take note that as the concentration lowers, we try to find a more convenient way to express it so as to avoid the chances of error. So milliequivalents when you talk of milliequivalents, automatically you are going to consider the valence or the combining capacity of the compound or the substance. So in milliequivalents, we need to consider the valence or the combining power of a substance. While in millimoles, while dealing with millimoles, we deal with the number of moles. We deal with the number of moles. You need to take note of that. After understanding that, everything shall proceed as usual. Valence in milliequivalents, because it takes note of the valence. So to know the milliequivalent, you need to take note of the valence, the total number of particles in solution, and to know the number of millimoles, you need to know the number of moles. Okay. So this is a unit of measure, and it is related to the total number of ionic charges in solution. And as I said before, it takes note of the valence of ions. In other words, it is a unit of measurement of the amount of chemical activity of an electrolyte. Okay, so this milliequivalent. So if let's perform a simple logical test. If the equivalent weight is expressed in grams, then the milliequivalent weight should be expressed in milligrams. That is what to consider. Now, let's check this. If we were to look at the milliequivalents of sodium, then the milliequivalent should take note of the valence of sodium. Sodium has got the valence of 1, so the milliequivalent shall be equal to the equivalent weight in milligrams divided by its valence. So sodium has got the equivalent weight of 23 and the valence of 1. This means that 1 milliequivalent of sodium is going to provide 23 milligrams of sodium. I think that is clear. 1 MEQ is going to provide 23 mg of sodium. Let's check another example. If we are looking at the milliequivalents of chlorine, chlorine has got the molecular weight of 35.5 and the valence of 1. So equivalent weight, or the milliequivalent, is equal to milligrams of a valence of a specific substance. Then the milligram here, this is 35.5 divided by 1, then you get 35.5 mg. To conclude, you say that 1 MEQ, 1 milliequivalent of chlorine is provided by 35.5 milligrams of chlorine. So the total compound, sodium chloride, is provided by 58.5. Why? This is 23 mg provided by 1 MEQ plus 35.5 mg provided by 1 MEQ. So 1 MEQ of sodium chloride is provided by 55.5 milligrams. That is simple like that. Let's check another example. Let's perform another logical test on calcium. Let us find the equivalent weights of calcium. So calcium is positive 2. So amount of milligrams of calcium is 40. And the valence, and that is 2 positive. So the equivalent weight, 1 MEQ, is provided by what? Milligrams over valence. And that is 40 over 2. So 40 over 2, you get 20 milligrams. Okay. All right, so here, 1 milliequivalent can provide 20 milligrams. 1 MEQ of calcium can provide 20 milligrams, meaning that 40 are going to be provided by 2 MEQ. 2 MEQ of calcium will give you 40 milligrams. How? This is simple. If 1 MEQ gives you 20, then 40 is given by how many? And that is 2 milliequivalents. So to summarize, calcium has got an atomic weight of 40. So 40 milligrams of calcium in solution means 1 millimole of calcium is in solution. In this case, 2 milliequivalents of calcium are in solution. Okay. Therefore, the amount of salt containing 1 milliequivalent of specified iron is calculated by the following. Amount of salt containing 1 milliequivalent. Check this. Amount of salt containing 1 MEQ is calculated as follows. So milligrams of salt containing 1 MEQ are calculated by taking the molecular weight of salt divided by the valence of a specified iron, times number of specified ions. Let me repeat this. If you have been told to find the amount of salt containing 1 MEQ, the formula is consider milligrams of salt because we are looking at the amount of the whole salt, so the formula should contain salt. And the molecular weight to be used is for the whole salt because we are looking for the amount of salt. But the valence to be considered is that of a specified iron. So consider the specified iron times the number of specified ions. Let's check an example here. How many milligrams of calcium chloride? So how many milligrams of calcium chloride? Okay. How many milligrams of calcium chloride are needed to provide 1 MEQ of calcium and 1 MEQ of chlorine and 1 MEQ of chlorine. So this kind of calcium contains water with 2H2O. So how many milligrams of calcium chloride? That is with the water. It has got 2 molecules of water. So we need to know how much of calcium chloride contains 1 MEQ of calcium and 1 MEQ of chlorine. So consider this. How many milligrams of calcium chloride means the amount of salt. containing 1 MEq of what? Of calcium and chlorine. So the ion spoken about here is calcium and chlorine. So if we begin with calcium, so milligrams of salt, consider they're all salt. That is calcium chloride. Its molecular weight is 147 here. So 147 molecular weight of the all salt divided by the valence of a specified ion. So here the specified ion is calcium, then its valence is 2, times number of specified ion, it is only 1 calcium specified. Then you get the amount of calcium. Then for chlorine, milligrams of salt equivalent to the molecular weight of the whole salt. So here, then the valence of specified ion, this is chlorine with 1. Number of specified ions, this is 2. Why? When you dissociate this equation, calcium chloride gives you calcium plus 2 chlorine. Then that is 2 there. Thereafter, you get 73.5 milligrams, 73.5 milligrams. In total, you get 147. So, that is to say, 1 milliequivalent of calcium will provide 73.5 milligrams of, 1 milliequivalent of calcium chloride will provide 73.5 milligrams of calcium, and 1 milliequivalent of calcium chloride will provide 73.5 milligrams of chlorine. All right, let's check another example. Let's check another example. So when grams or milligrams of salt are stated, the number of milliequivalents can be obtained by proportional. This is the vice versa of what we are doing. So when grams or milligrams of salt are stated, the number of milliequivalents can be obtained by proportion. How does this happen? Check this example. How many milliequivalents of sodium are contained? Let me write this. How many milliequivalents of sodium are contained in 351 milligrams of sodium chloride? This is simple. So you can see the number of salt is stated. So it is stated in either milligrams or gram. If the number of salt is stated here in terms of grams or milligrams, then number of milliequivalents will be obtained by proportion. How? What you need to know is to consider this salt. This is sodium chloride. So how much sodium is provided by 1 milliequivalent? 1 milliequivalent of sodium chloride provides 58.5 milligrams. So how many milliequivalents can provide? 351 mg. Or in the other way around, if 58.5 milligrams of sodium chloride provide 1 milliequivalent, then 351 milligrams of sodium chloride provides how many MEQs? Then if we divide, you get 6 milliequivalents. That's it to say 351 milligrams of sodium chloride are provided by 6 MEQ. So to make it simple, when converting millimoles to milliequivalents or vice versa, millimoles are equivalent to milliequivalents over valence. So by using this proportion, you may change the equation either or, in millimoles or in milliequivalents. Okay, let's have 3 to 4 more examples. Question number 2 states that the solution contains 90 milliequivalents of sodium, 60 milliequivalents of potassium, and 150 milliequivalents of chlorine per liter. Convert this to gram per liter. So this solution, this was a solution which had both cations and anions. So we have sodium, potassium, and chlorine. So probably chlorine came from sodium and potassium. So milliequivalents of sodium, we have 90 milliequivalents, and milliequivalents of potassium, we have 60 milliequivalents. So summing this, you get 150 MEQs of chlorine. So this was in 1 liter. So these were milliequivalents per liter. This solution was a 1 liter solution. So we need to change this into gram per liter. How do we do it? This is simple. You may start one by one. To convert to gram per liter, start with sodium. So in fact, before dissociation, this was sodium chloride. So you need to know how much sodium chloride is provided by 1 MEQ. And up to now, that is obvious that 1 MEQ provides 58.5 milligrams of sodium chloride. So if so, 90 MEQ are going to provide how much? So 58.5 times 90, that is equivalent to 5265 milligrams per liter. So to convert to gram per liter, divide by 1,000, then that is 5.265 gram per liter. Then you do the next to potassium. You should know how much potassium is going to provide 1 MEQ. That is obvious. 1 MEQ of potassium chloride can provide 74.5 milligrams of potassium chloride. So if we have 60 MEQs, then shall provide how much? Then that is 470 milligrams per liter. Converting to gram per liter, divide by 1,000. That is 4.470 grams per liter. To get the amount of chlorine, then that is the amount of sodium plus the amount of potassium. Together they are going to give you chlorine, because chlorine dissociated from both. Okay, let's have 2 more examples on this. We have this interesting question here. What is the concentration in milligrams per milliliter of a solution containing 2 milliequivalents of potassium chloride per milliliter? So we have been asked to find the concentration in milligrams per mil of a solution. A solution contains what? A solution contains 2 milliequivalents of potassium chloride. Okay, what is the concentration in milligrams per milliliter of a solution containing 2 MEQ of potassium chloride per milliliter? So to perform such a question, you need to have at least 3 steps. First, find the molecular weight, then find the equivalent weight, then multiply the equivalent weight to what you got, then you shall have the number of milligrams required. So step 1, find the molecular weight of the substance. So that is potassium chloride. Its molecular weight is 74.5. Then the equivalent weight. Equivalent weight means the sodium chloride equivalent, the milliequivalent, the MEQs of the solution. Equivalent weight, remember, to get the milliequivalent, you need to have milligrams of valence, milligrams of a specific substance, and this is potassium chloride. So milligrams of potassium chloride divided by its valence, then its valence is 1, that remains 74.5 milligrams. So this means 1 MEq of potassium chloride can be provided by 74.5 milligrams. Then 2 milliequivalents in solution can provide how much? Then you cross multiply. That is 74.5 times 2. Then you get 149 milligrams per mil. That is the concentration. One more example. What is the concentration in grams per milliliter? So what is required here is the concentration in grams per mil of a solution containing 4 MEq of calcium chloride. A solution contains 4 MEq of calcium chloride, which contains 2 molecules of water per milliliter. So now this is our solution. The solution contains 4 MEq of calcium chloride with 2 molecules of water, and we need to change this concentration into grams per mil. First step, remember, find the molecular weight. So the molecular weight of the stated compound, this is 147 calcium chloride. Then find the equivalent weight, meaning the milliequivalents, meaning you need to have milligrams of a valence of a specific compound. So milligrams are 147. The valence of the whole compound is 1. That remains, that is 2. The valence is 2 of calcium chloride. So when you divide, you get 73.5. That is the valence, milligrams. So step 3, if 1 milliequivalent calcium chloride is provided by 73.5 mg, what about 4 milliequivalents given in solution? Then cross multiply. Then 4 times 73.5, that is 294 milligrams per mil. Remember our question is to convert into concentration of gram per mil, and these are milligrams per mil. Then you simply divide by 1,000. That makes 0.294 gram per mil, and that is your concentration. So that is how to go about milliequivalents. We shall be going now to millimoles. Thank you.